Hi, this is Alex from devstories.eu. Apache Cassandra with Python, Episode 1 of 12. Relational databases hit a hard wall when you try to deploy them across multiple continents. You end up fighting latency, downtime, or a brittle architecture where a single failing server takes down your write operations. Massive global scale requires a completely different database paradigm. That paradigm is Apache Cassandra. It is an open-source, distributed NoSQL database built for immense scale. When engineers first look at Cassandra, they often bring baggage from relational systems. They look for the primary node that handles writes and the read-only replicas that follow it. You need to drop that mental model immediately. Cassandra does not use a primary replica design. It operates entirely on a masterless multi-primary architecture. Every single node in the cluster is identical. Any node can accept a read request, and any node can accept a write request. To understand why it works this way, look at its history. Cassandra was originally developed by combining two major research breakthroughs. First, it took the fully distributed masterless network design from Amazon Dynamo. This dictates how nodes communicate, discover each other, and replicate data across the network. Second, it adopted the log-structured storage engine from Google Bigtable, which handles how data is physically written to disk. The result is a system engineered specifically for continuous availability across multiple data centers. Consider a global social network. You have active users in Tokyo, London, and New York simultaneously. If a user in London updates their profile, that write operation needs to happen instantly. Routing that request across the Atlantic to a single central database is too slow. With Cassandra, the user writes to a local node in the London data center. That node accepts the write locally and immediately takes responsibility for replicating it to Tokyo and New York in the background. Here's the key insight. Because every node acts as a primary, there is no single point of failure. Cassandra arranges its nodes in a logical ring. When data enters the system, a mathematical hash determines exactly which nodes in the ring own that specific piece of data. If a major outage takes the entire London data center offline, the social network does not go down. Tokyo and New York continue accepting reads and writes without interruption. When London comes back online, the other data centers automatically sync the missing data to the recovered nodes. You achieve true global availability with zero downtime. This masterless design also means scaling is predictable and linear. If you need more storage or more write capacity, you simply plug another node into the ring. The cluster automatically detects the new hardware and redistributes the load across the active machines. Cassandra forces you to trade the comfort of traditional database queries for something much harder to build at scale, the absolute guarantee that no matter what hardware fails, your database stays online and your operations succeed. If you want to help support the show, you can search for DevStories EU on Patreon. That's all for this one. Thanks for listening and keep building.